Hello, and welcome back to my 50-second try at recording the second part to operations and properties of roots. Today, it's still the same day. Now I will be showing you nth roots. The definition of nth roots is for any real numbers, a and b, in this case, and any positive integer, n, in this case, if a to the nth power equals b, then a is an nth root of b. And that's a really weird way of explaining what nth roots are, so we're going to look to this table over here, straight out of the book, because it does a much better job at explaining what they are visually. So x cubed equals 64. Now what could x be? It's 4, because 4 times 4 times 4, or 4 cubed, equals 64. So 4 is a cube root of 64, and therefore an nth root of 64. And the sentence down here says this pattern suggests the following formal definition of an nth root. Parts of the nth root. This number right here is called the index, and it indicates to what root the value under the radicand is being taken. And the radical sign is just basically the symbol itself right here. And the radicand, the number, is the value that is being taken to the nth root, which would be right here. Principal roots. When there is more than one real root and n is even, the non-negative root is called the principal root. And this is just white space. Whee! It's so much. Okay, find roots. Example 1. So we're going to simplify this, as it says in the directions, again, straight from the book. So what we're given is positive or negative square root of 16y to the fourth power. So to simplify this, we've got to get rid of this square root symbol right here, or the radical symbol in this case. That's the third time I've said that. Anyways, we're going to take this, and we're going to simplify it, specifically the numbers in here. Now, how do you cancel out a square root? You got to square it right here. So we, fortunately, can simplify both of these by square rooting both of them. So 16 square rooted equals 4, and y4 square rooted equals y squared. So then you get this. And then this and the radical sign can therefore cancel out and leave you with positive or negative 4y squared. So therefore, the square roots of 16y to the fourth power are positive or negative 4y squared. The next example is simplifying using absolute values. And this equation is fairly simple, as you can tell. We've just got 64 times x squared minus 3 to the 18th power and a radical sign to the 6th nth. Yeah, like I said, this is perfectly easy stuff, guys. So again, we're simplifying. So 6 and 64. What to the 6th power gets you to 64? 2 does. So 2 to the 6th power would equal 64, so then 6 and the 64 would cancel out to give you 2 in its place. And since these numbers here are inside a parenthesis, they are unaffected by this nth right here, except their exponent right here, 18. It gets divided by 6 because that's how variables work. So 18 divided by 6 gives us 3. And it says it right here, since the index 6, right over here, is even, and the exponent 3, right here, is odd, you must use absolute value, because this might have a possibility of being a negative number, and in the math world, you don't want that. So absolute values are a must. Okay, well that's apparently the end of the video. We don't really have a formal ending set up, so I'm just how about this? How about this, guys? Here you go. Here you go.